Describing three-dimensional figures. We're going to start with some vocab words and we're going to label the diagrams as we go through. So looking at a polyhedron. A polyhedron is a space figure or a 3D figure whose surfaces are polygons. So this model here is a polyhedron. All surfaces are polygons. Polygons are figures that have sides. So a square, a rectangle, a triangle, something like that. Each polygon is a face of the polyhedron. So this side here, shaded in orange, and this side here that's already shaded in purple, both represent the face of a polyhedron. And each face is a polygon, a four-sided or a straight-edged figure. An edge is a segment that is formed by the intersection of two faces. So where two faces come together, such as right here, or we could say right here, or any two sides that come together is called an edge. A vertex is a point where three or more edges intersect. So for vertices, where corners intersect, or where all polygons, all sides, all faces, however you want to say it, intersect, creates a vertex. And lastly, for our vocab is a geometric net. And a geometric net is a flattened out 3D object. When you cut out the net, you fold it and glue it together. You can see it in the example over here. So this is an example of a net. Of course, this year we're obviously partly virtual, so this is a difficult thing to show. But if you were to cut this figure out and you were to fold it along the dashed and solid lines, you could fold it into this shape. It creates a polyhedron. If we move down to the examples where we're identifying vertices, edges, and faces of the polyhedron. So before I start, let's just analyze this briefly. I see that I have a rectangle or a square, we don't know exactly, but the base is a four-sided figure. And then I see that I have all sides that appear to be triangles. So every side of this figure is a triangle that comes to a common point. So for vertices, vertices are where the sides or the faces come together. I'm just going to count how many I have. So 2, 3, 4, 5 of them. They are located at points A, B, C, D, and E. Edges are where two faces come together. So if I trace over all the edges, I have an edge here, here, here. So that's 4, 5, 6, 7, 8 edges. Labeling them, I'm going to start with right here, AC. Then I'm going to look at this one here, which is segment AB. In the back, I have AE, AD, ED, EB, BC, DC. Did I get them all? That's all of them. Okay, and as far as the faces go, so the faces of this figure, looks like we have the base, which I already highlighted in green. Then we have this side here, which is a triangle. We have this back side, so that makes 3. We have this side here, that's 4. And we have that side, or this front side, which is 5. So we have 5 faces total. If I label them, starting with this face, that would be a triangle, triangle ADC. Starting, or now looking at this face, that's triangle ABC. Over here we have another face, ABE, triangle ABE. We have this triangle ADE. And we have this base that's already highlighted in purple, which I'm going to label as a quadrilateral because it's 4-sided. So quadrilateral BCDE. And that's labeling all of the faces. Okay, moving on to the next part. We're looking at right solids versus oblique solids. So a little bit more on the vocab. So a right solid is a solid geometrical figure whose axis or lateral edges are perpendicular to its base. So you can see here that we have a figure that forms right angles all the way around. So its base is perpendicular to its lateral edges. That is what makes it a right figure or a right solid. We're comparing this to what we call an oblique solid. So an oblique solid is a solid whose bases are not perpendicular to the lateral edges or it's slanted. So think of this as a cylinder. Maybe think of a stack of pennies, and then you take the stack of pennies, if you just kind of push it with your finger, you can make that stack slide to the side, so it's no longer standing straight up. That's what I wrote right here, but that's a good way to think of an oblique solid, something that's slanted. So slanting is the biggest term to think of when you think of oblique. Now let's jump into some polyhedrons. So we're talking about 2 different types. We're talking about prisms and we're talking about pyramids. So starting with prisms. A prism is a polyhedron with exactly 2 faces that are congruent and parallel. These are called bases. That's very important. The other faces are called lateral faces. So based on what I just highlighted, we have 2 sides of this figure, the 2 sides that I'm currently highlighting, that are congruent and parallel, so the top and the bottom. If you were to hold this figure in your hands, the bases of that figure, one would be on the top, one would be on the bottom, and they would never touch, so your hands would be separated between these bases. That's what this is labeling. The other faces are called the lateral face, so I'm labeling this side, which is shaded in gray, as the lateral face. Any side that is not considered a base is called a lateral face. A polyhedron in which one face is the base, which can be any polygon, and the other faces are lateral faces that meet at a common vertex, are called, or this figure is called, a pyramid. So in this figure, we have our base. We only have one base for a pyramid. So the 2 important things to think of when you think of a pyramid is identify the base and identify the vertex. Because the vertex right there shows that this is in fact a pyramid. So far we labeled the base and the vertex. Of course, the other side is called the lateral face. So just take a moment and compare these 2. Compare a prism and a pyramid. A prism is something that you could hold between your hands. Your hands will never touch because each hand is touching a base of the figure. Think of a soda can. That might be a bad example. Think of a cereal box. Okay, a cereal box would be an example of a prism. Whereas a pyramid has a point. It comes to a point. Think of an actual pyramid. They are two different figures. You have to know the difference between them. So polyhedrons, or sometimes you'll hear it called polyhedra, are named by the shape of their bases. So if we go back up to these two models, the prism, the base is a pentagon. So we call it a pentagonal prism. If the base was a triangle, we would call it a triangular prism. If the base was a rectangle, we would call it a rectangular prism. For this pyramid, the base of this pyramid is what appears to be a square, so it could be a rectangle, but I'm going to go with a square. So we're going to name this a square pyramid. Okay, so now in the next section, we are naming these figures. So we're naming them based on if they're a prism or a pyramid, and we're also naming them based on their base. So number one definitely has two bases, so you can either think of it as these two sides that I'm highlighting, or you can think of it as another two sides. But no matter what, this is going to be a prism. And you can see that all sides are a rectangle, so I'm going to call this a rectangular prism. Number two is the biggest mix-up that students make. So many students want to call this a triangular pyramid, but that is not a triangular pyramid. Take a look at number two and number five. Number five is a triangular pyramid. Number two is a prism. Number two has bases that are both triangles. If you held this between your hands, you would be touching both of those sides that I just highlighted in green. So this right here is called a triangular prism. It's the biggest mix-up. Everyone wants to just automatically call that a pyramid. It is not a pyramid. Number three, we see two congruent bases, both of which are pentagons. So this here is another example of a pentagonal prism. Number four. Number four has a base of a hexagon, but then it comes to a point, a common point, or the vertex. So this is called a hexagonal pyramid. Number five, we have a triangle and we have a common point where all the lateral faces touch. This is called a triangular pyramid. And lastly, we have a square base and all of the lateral points, all of the lateral faces come to one point. This is called a square pyramid or a square base pyramid. Next, we're looking at a few figures that are not considered polyhedrons. And I actually jumped ahead a little bit on the previous example when I used a soda can as an example. A soda can is not an example of a cylinder. I'm sorry, I keep mixing up my terms. It is not an example of a prism. It is, in fact, an example of a cylinder. So that's what I was thinking when I said that. So a cylinder is a solid with congruent parallel circular bases. All right, think of a soda can. You have two bases that are circular. Think of a stack of pennies. Think of, what else? Anything that's a tube. So paper towel, the inside of, or just a paper towel roll in general, the top and the bottom, that would be an example of a cylinder. What I just highlighted are called the bases. We have a cone. A cone is something you all probably know of as well. So a cone has a circular base and it comes to a vertex. Think of a cone as an ice cream cone. That's the easiest way to think of it. Or maybe a hat, like a cone that points to a vertex. And lastly, we have a sphere. So a sphere is a set of points in space that are the same distance from a given point. A sphere has no faces, edges, or vertices. So any ball, basketball, soccer ball, tennis ball, anything like that, baseball, that is a sphere. So it's a three-dimensional object. It's a perfect sphere. A lot of people refer to it as a circle. It is not. However, a cross-section of it is a circle. A sphere has a radius, and you need that radius when we start looking at volume. Okay, moving down to name each figure. Now I threw a little curveball in here. Number one. Number one looks like a cone, but it's slanted to the side. So we're going to call this an oblique. We talked about oblique versus right figures. So an oblique cone. Number two, that's just a regular cone, a right cone, or just a cone. And number three is a cylinder. Okay, we have a couple more geometric figures to name. The next section is talking about cross sections. So a cross section is the intersection of a solid and a plane. It is the two-dimensional shape we get when cutting straight through an object. So in typical years, I would bring like fruit and vegetables in and I cut them, and you can see what you think the cross section is. This year, not so easy, so what we're looking at is just a diagram. So if I was to bring in an orange and I was to cut an orange in half, and you were to look at this figure right here, what would you say the two-dimensional object would be? And hopefully you would all agree that that is a circle. So you would say the cross-section of an orange is a circle. So if we look at the examples here, number one, if I ask you to cut a cylinder, so you cut it where you see that blue slice, what is the cross-section? So what would this figure be? So for a cylinder, let's think if you were to cut well, let's just use a paper towel roll. So if you were to cut a paper towel roll in half and you were to pick it up and you were going to look at those cuts, what would you see for a shape? And hopefully you all agree that you would see a circle. If you cut that paper towel roll on a slant, you would most likely see an oval. Now, if you were to cut that paper towel roll straight down from the top and you were to look at the two-dimensional shape, you would be looking at, of course, it's rounded on the top, but you're not looking at the top. You would be looking at what is called a rectangle. Trace over your cross section here. That would be a rectangle. So cross sections are 100% a visual topic. You need to really think about what you're going to see when you cross through or you cut through an object. Think about real life objects that you cut through and think about what you would see as a two-dimensional shape after that. And the last part of today's notes is talking about solids of revolution, which is a huge topic when you get to like things like three-dimensional calculus and beyond that in math classes. For geometry, we are talking about the bare minimum of a solid of revolution. And this would be a solid that is obtained by rotating a plane figure in space about an axis coplanar to the figure. The axis may not intersect the figure. So think about if you attached a rectangle to a pencil and you roll the pencil through your hand super fast and you see the the rectangle moving around and around, what shape would it be creating? And it would be creating, in this case, a cylinder. Number 2, if you were to rotate a semicircle, a half circle around that pencil, run it through your hand super fast, what would you be forming for an object? You would be forming a sphere. And number 3, this would form a cone. So again, solid of revolution is something that is extremely visual. You definitely need to think about what you would see. I know talking about attaching a shape to a pencil would be the best way to visualize it. That's what I usually do in class with students, just move it really fast and see if they can visualize what the figure would be. But whatever you need to do to think about what the shape would be. And that's it for the vocab and the topics for today. So please let me know if you have any questions.